Okay, so we are live. Let me share the screen. So guys, our today's lead course POTD is maximum score after splitting a string, where we have been given a string and we need to split the string into such a way that like we can split it into a number of ways, but we need to calculate a way in which our left substring has maximum number of zeros and our right substring has maximum number of ones. So for example, if we split our string at like of our left substring of 1 of having length 1 and our right substring of having the rest of the length, so our total score will be 1 plus 4, as it is having 1 0 in the left and 4 ones in the right. And if we see another ways, we can see that there is none of the other ways which is giving us a max output as we have been getting in our first case. Similarly, in our second example, if we see our string 0 0 and triple 1, and if we split our string in the way like in of left substring of length 2 and right substring of the remaining length, we will get our max score of 5. So how we can approach this question is, first of all we can just simply take one answer variable as 0 and start iterating our string from I equal to 1 to less than extra length, and then we can first of all split our substring dot string 0 comma I. Okay, it will be string, and our right substring as
Mm,
from
please
I
give us-
till the end, and we can just store our maximum in our answer. Mm, plus count, and we can simply return our answer at the end. So let's check our code. Okay, it's giving us an error of let's just simply convert it explicitly to int. Okay, so now let's try submitting it. Okay, so as you can see guys, it got submitted. It was just a simple question where we are just splitting our left substring and the right substring in the number of iterations, or the according to the number of length of the string, and we're simply counting the number of zeros in our left substring and number of ones in our right substring, and then simply calculating the maximum value that's possible, and after that we are just simply returning our answer. So that was all for our lead course POTD. Okay, so now over to you, Sangam.
See, guys, the question that we have been asked today is in today's lead code PODT is that there is an like two array that is given to us. First will be the starting array, other one will be the finishing array. The starting array dictates the starting time of meetings that is getting placed at that moment, and finishing time is the moment that when this meeting finishes. Now we just have to return the maximum number of meetings that we can confront or we can do in that meeting room such that the starting time and the ending time of the meeting should be different. Now what does this means? So let's just keep an example that the meetings that we have been given is 1 2 and then 2 3 and then let's say 4 5. Yeah, so starting time is at 1, the ending time is at 2. Then for the second meeting, the starting time is at 2 and the ending time is at 3. And for the third meeting, the starting time is at 4 and the ending time is at 5. Now we can pick this one because it is the beginning one, so we can actually pick this one. Now, the condition that we have been provided here is that the ending time of the meeting and the starting time of the next meeting, they can't be same. As in this case, you can see they both are same, so we cannot include this one in our meeting room, because during this time this second meeting is going to start, our first meeting is already ongoing, so we can't actually let other people move out from the meeting room. So we are simply going to ignore this one. Then we can consider this one. So as you can see in this case, the starting time for this meeting was what, 1, but the ending time is what, 2, and for the starting time of this meeting is 4. So in this way you can see that if the meeting ends at 2 p.m., then I can constitute or do another meeting at 4 p.m. So we can actually include this one in our equation, and as a result such a total of 2 meetings is what we can conclude during that time. Now here is the given array that we have been provided in this question, and if you look carefully, there are actually 4 pairs that we can literally see from here. One would be that we pick this one, 1 2, then we pick 3 4, then we pick 5 7, and then we pick 8 9. Yeah, we can pick this one, and the answer that we are going to get would be 4. And the basic notation that we can apply in this case is that just pick the end time of current meeting, which will be our I, and compare it with the starting time of the next meeting, which will be I plus 1. Yeah, and then just see that if the end time is smaller than the starting time, then yes, we can actually include that meeting in our equation. Now if we solve this this question via this method, yes, we are going to get solution in these types of question. But the issue arises when we have equations something like this, in which the starting time, as you can see, if we do try to solve this question via this method, then we can see that yes, we can include these two meetings, so it will be 2, but we can't include any of the further meetings that are available on this side, because if you see the ending time is 9, I can't, if this meeting is finishing at 9 p.m., then I cannot consult another meeting on that same day at 1 p.m., because 1 p.m. had gone past, so we can't consult all that thing. So if we look at it carefully, we can actually include this one in our answer. But how we are going to do this thing if we are trying to do this solution via this approach? So that is why in this problem we are going to apply greedy approach, greedy method. And it is quite simple method. But in greedy method what we do is we just try to figure out what will be the optimal choice at that particular moment. Yeah, what will be the optimal choice, and we are not concerned about the future. Okay, unlike DP, in which we are concerned about the future, in greedy we are not concerned about the future. Okay, so we are just going to look at the optimal choice. Now the question arises, like, how we are actually going to make sure that we are including these 3 elements and not these 2. Like, how can we even do that? So what we are going to do to solve this problem via greedy is that we are going to sort this matrix of starting time and end time, starting time and finishing time, but we are going to sort it on the basis of finishing time, and we are simply going to ignore the starting time. Okay, and I will tell you what would be the reason behind it. So let's say this is the given matrix, and if we sort it out on that basis, what we are going to get is 1 2 will be the first one, then it will be 3 4, then it will be 0 6, then it will be 5 7, then it will be 8, yeah, 8 9, and then it will be 5 9. So now when we do this thing, sort it out on the basis of finishing time, we can simply look at the solutions via this approach. And now if I apply the like this similar logic on these sorted array, we are going to get the answer. And that is what greedy do. What greedy do is it is trying to find the optimal solution out of it. Now if we apply the same principle on this matrix, so as we can see, this is the starting time and this is the finishing time. So its sorted order would look something like this: 1 2, then will be 3 4, then will be 5 6, then will be, it will be 6 7, and then will be 8 9. Yeah. And if we do it via this method, we are simply going to get what we want, our answer in the form of the solution that we want, by applying this method. So only if we just sort the array out on the basis of finishing time and simply apply our this logic, then we can simply resolve the situation where we are not sorting out and facing the issues like regarding this. And that is what greedy will help us to do. What we are doing, or why we are saying that we are using greedy in this method, is because we are just looking for the current, we are just simply ignoring what will be the future consequences that we are going to face by sorting this matrix out on the basis of finishing time. We are simply ignoring that. What we are concerned about is the fact that, what, I just wants to sort them out. I just want to find the current answer. I don't give a fuck about what the future answer would look like. And that is what we are doing in this case. By sorting out, we are just assigning element, then simply we can compare them. And unlike this scenario in which we are facing the issue of 6 and 8, or 7 and 9 first, and then 1 2 and 3 later, in the greedy method we can just sort that thing out and we'll get our respective solution. So now let's just see how we are actually going to do this thing. So first of all, what we have done is we have put the elements in our vector pair. Okay. And in vector pair, what we are simply doing is we are just entering the starting array, entering the finishing array, and entering the index in that array. Then we are simply going to, sort this function out on the basis of comparison function. Now why I am using this another iteration or another element in my sort function is because this function will be sorted on the basis of this comp function. Now why is that? Because I want to, there are three elements that are available in a pair. First one will be the starting index, second one will be the ending index, and the third one will be the index of the array. And I want to sort out on the basis of finishing time. Now if I simply just use the sort function, then it will sort on the basis of these three values. But I just want to be like my array to be sorted on the basis of finishing time. So that is why I had applied this comparison function. In this comparison function, I'm simply saying that if the index is smaller than the index of the next element, that is the finishing time of first is smaller than then next, then simply return true, that is sort it out. Otherwise do not sort it out, as here I am returning false. Now if two finishing time are same, as you can see in this case, the finishing time are same, it is 8 9 and 5 9. That is why we have employed this condition here, that if the index of the first finishing time, which is this one, is smaller than the index of the next one, then simply keep the sorting function, and otherwise return false. Then after that, the next thing that we are doing, we are then simply comparing or applying this logic, that the ending time of current one should be smaller than the starting time of the next one. That is what we are doing in this for loop. And after we have got the answer, simply sort it out, because that is what the compiler of GFG is asking us to do, and then simply return the answer with respect to this question. So with that, guys, let's just compile it out. And as you can see, it is working perfectly fine. So with that, today we have solved both GFG and Leetcode POTD. We hope that you guys be able to understand it. With that, over to you, Shivam.
So yeah guys, thanks for joining with us. We will catch you up tomorrow. Okay guys.